All right. Another concept related to the related to the inner products of two vectors is the concept of orthogonality. All right, orthogonality. What is orthogonality? You can this is similar to the concept of perpendicular vectors. All right. Again, we return to our analogy of normal physical vectors. If I had a vector A, if I have a vector A and I have another vector B, what is the condition that I can say that this vector A is perpendicular to this vector B? Well, you know from your earlier studies of vectors that this we can say that two vectors are perpendicular to each other if their dot product is 0. Okay, if their dot product is 0. So we use the term perpendicular for physical vectors. When we talk about more abstract vectors and more higher dimensional vectors, we don't use the term perpendicular, we use the term orthogonal. Okay, but conceptually they are very similar. All right, so for physical vectors we defined perpendicularity using this relation. Okay, if two vectors follow this relation, dot product of them is 0, then we call them perpendicular. Similarly, in a complex vector space, if we have an inner product and we want to define the orthogonality of two vectors, we suppose we have two vectors u and v, then we say that u and v are orthogonal if and only if their inner product is 0. Okay, u and v, their inner product is 0. Entirely similar definition. For physical vectors, we used to say that two vectors are perpendicular if their dot product is 0. For in complex, more general complex vector spaces, if we have defined an inner product, then we will say two vectors u and v are orthogonal if their inner product is 0. One thing to notice here is that we need to define an inner product. We need an inner product if we want to define orthogonality. If we want to define orthogonality. Okay, without the definition of an inner product, we cannot actually define the relation for orthogonality. Okay, all right.